Hi there, this is Mrs. Schlecht, and in this video, we're going to go over the constant of proportionality. All right, my friends, before we get started, you know there's going to be a few materials that you need in order to be successful for this video. First, you're going to need your Envision textbook. That's the one with the little robot man on the front. Second, you're going to need your math notebook to take those great and beautiful notes. Third, you're going to need a pencil. And fourth, last but never, ever, ever least, you're going to need that positive math attitude. All right, so this video goes with lesson 2-4 inside your Envision textbook. And the key concepts page for this lesson can be found on page 110. Please make sure, my friends, that before you start this activity, make sure that you've gone over lesson 2-3 because 2-3 kind of gives us like the first piece, and now here's the second piece of what we need to do, okay? So let's get into some of the fun and crazy. It's not that crazy, but it's still really fun. Anyway, some of that math we're gonna do. All right, full disclosure, my friends. I really felt like I was getting a hang of these whole like ratios and proportions, and I felt like I knew how to teach you, right? And then all of a sudden, this term came up, constant of proportionality, and Mrs. Schlecht's head just about exploded because I was like, whoa. Wait a minute, math. I thought I knew what I was doing, and now you're throwing this whole thing in, right? Okay, so if you're like me and this kind of freaks you out, take that breath because it's actually really simple. You remember that last video we were looking for like those equivalent ratios, right? And like how we could represent that pattern, that proportional relationship between each of those ratios. All right, but here's the new piece. We're just trying to make an equation. That was it. Oh my gosh, something that sounds so big and scary. Actually something really, really simple. We're just trying to put it into an equation, right? An equation that represents that proportional relationship, represents that pattern between all those different ratios that I'd be able to then use to predict maybe the terms that I don't really have all the information for quite yet, right? So the formula, the equation that we're going to try to get with, and this is on page 110 in y'all key concepts, my friends, is y, which we can kind of think is like our output, times k. K is like our constant of proportionality. K is like what I'm doing, okay? Times x, and x is kind of like our input where we start with, okay? Couple of really important things. You ready? Okay, so you ready? Here's an important thing. For all this like proportional stuff, constant proportionality, all that type of stuff, 2 operations you're thinking of, my friends. You ready? Multiplication, division. Multiplication, division. That's it. Even if it looks like, oh, there's like some addition patterns here. I don't care about addition. I don't care about subtraction. That's not going to make this proportional, all right? Again, the only 2 operations that I care about for this, multiplication and division. That's it. Hey, are you ready to like put this to the test? I know I am. Okay, a couple of things. One, first problem we're going to look at is on page 111, and it's number 13. I also, over here, just wrote down that formula that we're going to try to use for that constant of proportionality, just to like help remember, right, kind of our end goal, where we're actually trying to get to, okay? So again, y equals k times x, right? K is that variable, that thing that we're going to be multiplying by each time in order to get my y, right? So I have my x, that's my starting point. I'm going to do something with it. That's my k. My k is, I don't know, something, right? And then y is that output. All right, my friends? So again, we're on page 111, looking at number 13, kind of keep this formula in mind. All right, let's get started. All right, my beautiful people, let's talk about number 13. So a couple of different pieces of information going on here, all right? We got Anne's car, vroom, vroom, vroom. It goes 228 miles on 6 gallons of gasoline. All right, my friends? So ignore this part real quick, but I just wrote that as a ratio. So the number of miles, 228, over the amount of gas, my gallons, right? 6 gallons over here. You'll notice also, my friends, in part A for number 13, it tells you that in this equation, right, this is kind of our end goal. This is where we're trying to get. Y is going to equal the distance traveled. So in this case, that would be 228, all right? X is representing the number or the gallons of gasoline that I have. And right now that is representing 6, right? But my K is, well, how do I get from 6 to 228, right? What do I have to multiply by 6 in order to get 228? That's what we're going to try to figure out. All right, my friends. So my first step is I'm going to make this into a unit rate. If you remember, a unit rate is when you have 1 as the denominator. So essentially, my friends, I'm trying to say, okay, if I can go 228 miles on 6 gallons of gas, okay, how far can I go on 1 gallon of gas? So that's the first part we need to figure out. All right, so here's how we found the unit rate. If you remember, we started with 6 gallons of gas, but I want to see how much I get for just 1 gallon. So in order to get from 6 to 1, remember, multiplication division only, my friends. In order to do that, I needed to do 6 divided by 6 gave me 1 gallon. Remember, whatever you do to the bottom, gotta be fair, gotta do it to the top as well, right? So now I'm gonna take 228 miles and I'm gonna divide that by 6, and that will tell me, well, on 1 gallon of gas, oh, you can go 38 miles on 1 gallon of gas. Pretty cool. So now let's take this new piece of information and can we plug it into that this little like formula over here that I'm supposed to be using? Yeah, you can totally do that. Oh my gosh, my friends, we're like on the verge of writing our first equation of constant proportionality. All right, my friends, let me explain all this goodness that we got going on here, right? Again, this is our whole end point, right? This equation, this formula represents our constant of proportionality. And that, my friends, is our main objective for this video, correct? Correct. Yeah. Okay. So I know that y is the distance that I was able to travel. So again, that's in miles. So y. Remember, k, that's what I'm doing. That's my change. That's the thing that's actually happening, right? And after we found this ratio and we made a unit rate, if you remember, my friends, we found that each gallon, that's my x, right? X is my gallon of gas. Each gallon of gas is going to get me 38 miles, right, per that gallon. So we're able to put it in this beautiful equation right here, right? Y equals 38x, my friends, which is representing that proportional relationship. But wait, there's more. All right, so part A for number 13, that's that bad boy right there, right? Y equals 38 times x, right? But there's part B. So now let's look at part B. All right, part B, we're still going to use that same formula, my friends, because that's our constant of proportionality. That's our pattern, right? But now, instead of just having 6 gallons of gas, I got 7 gallons of gas. So the question is, well, then how does that impact my Y, right? So if I have 7 gallons of gas, how many miles can I go? All right, my friends, so for part B, right, it's telling us that I have 7 gallons of gas that I am using in my car, all right? So we're still using this same formula because that's our constant of proportionality, right? This is our equation that represents that pattern, my friends. So now I'm just gonna plug and chug, right? Plug in 7 instead of x, and then chug it as in, do that operation, and that will get you your answer. So I also kind of rewrote it like this, my friends. Y, that's asking how many miles can I actually travel, right? That's my unknown, don't know that piece yet. 38, that's gonna stay the same because that's my pattern. That's what I'm doing each time that I add 1 more gallon of gasoline, I'm adding 38 more miles, right? And 7 is in parentheses because I'm going to be multiplying 7, which is my x, by k, which is my constant of proportionality, to find out my y, which is the number of miles I travel. Check it all, this sweet math, my friends. So we had our constant of proportionality, right? That's that equation that's representing this proportional relationship, that's representing these patterns, my friends, right? So y is actually going to be the distance traveled, right? 38, that's how many gallons I can go, or how many miles I can go with 1 gallon of gas, right? And then I had 7 gallons of gasoline. So when I multiplied that, I found out that if I had 7 gallons of gasoline, I would be able to go 266 miles. All right, I hope you can handle all the fun that we're having right now. There's one more problem that I want to go over together. Still on page 111, but now let's look at number 10. All right, my friends, so number 10, a couple of different things going on, right? So our big ratio is we're comparing zinc to copper. So for every 3 grams of zinc that I have, I need 16 grams of copper, okay? So that's our proportional relationship. And then it's asking us eventually to find out, well, if I have 320 grams of copper, how many grams of zinc do I have, okay? So first, my friend, let's look at this piece right here. This 3 grams over 16 grams. I'm going to divide that because I want to know what K is going to represent, right? And remember, K is that pattern. What's the pattern of what's happening here, okay? So again, my friends, we're going to try to figure out, well, what's 3 divided by 16? All right, my friends, so let's check this out. So when I divided 3 over 16 to get that constant proportionality, which is K, right, we got 0.1875. So 1,875 10,000ths, my friends, is what we got. And that's that K. That's that piece that will be our pattern, right, our proportion. So now, my friends, I put it just into this equation over here, which I just kind of sort of modified from this bad boy over there, right? Y is the amount of copper, right? That's what I'm trying to figure out. K, that's my constant of proportionality, right? That's my decimal. That's what I'm doing to my X in order to get my Y, right? And then, of course, X is zinc. So we can think about it like this, my friends. I did 3 times 1,875 10,000ths, and that's how I got 16. So we're kind of playing around with that, right? All right, so here's how we're going to do it now, my friends. I want to know what Y is going to, or what zinc is going to be up here, right? So now I need to solve for my unknown. So we could rewrite this equation. Rewrite this equation, right? Our constant and proportionality equation, like this, once I've kind of plugged in those factors, those values that I know, right? So I know that my copper needs to equal 320 grams because it says so right there, right? I know that I'm going to take my X, which right now is an unknown. I don't know what it is, right? But I do know that whatever I have for X, I multiplied 0.1875 by it, and I somehow got 320. Now, how do I undo multiplication? Divide, right? I'm going to do division. So this is what I'd like you to do, my friends. Please divide 320, divide that by our K, which is our constant proportionality, right? Divide that. So 320 divided by 1,875 10,000ths. Check it out, my friends. Once we did all that math, we found that X actually equals 60. So what that means is that if I'm keeping my proportion, right, keeping my pattern, we're staying in balance, if I have 320 grams of copper, that means proportionally I need 60 grams of zinc. My friends, that was just a quick run through of lesson 2-4, which talks about that constant of proportionality. If you have any other questions after watching this video, please let me know.